Good morning, everyone. See this water molecule. Why this water molecule has bent shape? And see this carbon monoxide molecule. Why this molecule has linear shape? To understand this, we should know the bond parameters. So, what is bond parameters? Bond parameters are physical properties that describe the nature of chemical bonds between atoms in a molecule. So, by using these bond parameters, we can understand the nature of that chemical bond, and also it useful for know the stability, reactivity, and structure of molecules. So these bond parameters includes bond length, bond strength, bond angle, bond order, bond polarity, and resonance. Now let's see these bond parameters one by one. See the first bond parameter, that is bond length. Here two atoms are bonded with each other. R1 is the first atom bond length and R2 is the second atom bond length. So the total bond length is R1 plus R2. So bond length means the equilibrium distance between the nuclei of two bonded atoms in a molecule is termed bond length or bond distance. This bond length is expressed in angstroms or picometers. So there are some factors which affecting this bond length, that is size of the bonded atoms, number of lone pairs of unbonded atoms, multiplicity of bonds, electronegativity difference, percentage of S character. See the first one is size of the bonded atom. In these molecules like carbon, silicon, germanium, tin, if the atomic size increases, bond length also increases. In groups from top to bottom, atomic size increases. So this atomic size directly proportional to bond length. Now tell me the increasing order of this molecule's bond length. Next one is number of lone pairs on bonded atom. See the example of ammonia, water molecule, and HCl. Ammonia has one pair of lone pairs and water molecule has two pairs of lone pairs. HCl has three pairs of lone pairs. If the number of lone pairs increases on the bonded atom, bond length also increases, because these lone pairs create a repulsion with bond pairs and it occupies more space. Because of that reason, bond length increases. In these molecules, the increasing order of bond length is like this. So this bond length directly proportional to number of lone pairs on the bonded atom. Next one is multiplicity of bonds. See the example of alkane, alkene, alkyne. In alkane, it has only one bond. How many electrons are needed to uh, form a single bond? Two electrons. In double bond, it required four electrons. In triple bond, it required six electrons. If the electron density increases on bonded atom, so the bond length also decreases. And see the hybridization. Alkane shows sp hybridization and percentage of S character is 50%. In alkene, it shows sp2 hybridization and percentage of S character is 33.3%. In alkane, it shows sp3 hybridization and percentage of S character is 25%. So here three factors remember, that is multiplicity, percentage of S character, and electron density. These three factors inversely proportional to bond length. If these three things increases, the bond length decreases. So if the percentage of S character increases, bond length decreases. If the number of lone pair increases, bond length decreases. If the electron density increases, bond length decreases. Next one is electronegativity difference. In halogens from top to bottom, electron negativity is decreases. Fluorine has the highest electron negativity and iodine has the least electronegativity. So if these halogens are bonded with carbon molecule, the based on the electronegativity difference, carbon and fluorine has the highest electronegativity, carbon has the less electronegativity compared to fluorine. So the difference, if the difference is increases, the bond length also decreases. So this bond length is inversely proportional to electron difference between the electron density. So this is the main factors which are affecting the bond length. Now tell me the increasing order of this molecule's bond length. Next is bond angle. See the example of water molecule. Here the oxygen is the central atom. This oxygen atom is bonded with two other hydrogen atoms. So bond angle means the angle between the orbitals that contain bonding electron pairs around the central atom in a molecule. So it is expressed in degrees and can be experimentally determined by spectroscopic techniques. So this bond angle gives the idea of orientation of orbitals around the central atoms in a molecule, and some factors which affect this bond angle, they are hybridization, steric repulsions, number of lone pairs on central atom, electronegativity of central atom, electronegativity of side atom. So see the first one is hybridization. If the percentage of S character increases, the bond angle increases. Now see the example of these molecules and tell me the increasing order of this bond angle. In sp3 there is 23%, 25 percentage of S character. In sp2 33% of S character, and sp 50 percentage of S character. So based on that you can give the increasing order of this molecule's bond angle. Next one is steric repulsion. Steric repulsion means the repulsion between electron clouds of neighboring atoms or groups in a molecule. So here the uh, same hybridization and bond angle increases with an increase in steric repulsion of side atoms. So here the molecule shows same hybridization, but if the steric repulsion increases, the bond angle also increases. Now see this example and see the oxygen atom is attached to the three different type of halogen atoms, fluorine, chlorine and bromine. So now the increasing order of this molecule's bond angle is this. And next one is number of lone pairs on central atom. If the number of lone pairs increase of central atom, the bond angle decreases. So here the same hybridization, these molecules show same hybridization, that is sp3 hybridization, but the number of lone pairs increase on the central atom, the bond angle decreases. This is important, please remember that. And here the methane there is no lone pairs. In ammonia one lone pair is there. In water molecule two lone pairs is there. So the number of lone pairs increases, the bond angle decreases, but hybridization is same. Next one is electronegativity of central atom. So bond angle increases with increase in the electronegativity of central atom. So here the oxygen, sulfur, selenium is bonded with the chlorine atoms. The electronegativity of these atoms is oxygen shows high electronegativity than selenium. So if the electronegativity is high, then the bond angle also increases. Next one is electronegativity of side atom. So bond angle is inversely related to the electronegativity of side atom. See the phosphorus atom, which is the central atom, it is attached to halogens, that is fluorine, chlorine, bromine, iodine. In halogens from top to bottom the electronegativity is decreases. So here the electronegativity decreases. So if the electronegativity decreases, the bond angle increases, because this is inversely proportional to bond angle. So these are the factors which affect bond angle. Next is bond energy. See, these two atoms are bonded with each other. So if you want to break a bond between these two atoms, it requires some amount of energy. So whatever energy we are using to break that bond is called bond energy. Now see the definition of this bond energy. The amount of energy required to break 1 mole of a particular type of bonds between two atoms in gaseous state is called bond energy, and it also called bond dissociation energy or bond enthalpy. So the SI units is kilojoules per mole. So there are some factors which affecting this bond energy is, that is electronegativity, difference of bonded atom, multiplicity, size of bonded atom and number of lone pairs of bonded atom. See, the first one is electronegativity difference between bonded atom. In halogens, from fluorine to iodine, the electronegativity is decreases from top to bottom. So when these halogens are bonded with hydrogen, for example hydrogen fluoride, hydrogen chloride, so the in fluorine has highest electronegativity. The difference between these bonded atoms increases. The electronegativity difference increases between bonded atom, then the bond energy also increases. So based on that, from hydrogen fluoride to hydrogen iodide, the bond energy is decreases. Next one is multiplicity. In hydrogen molecule, this hydrogen molecule is formed by uh, they form a single bond between two atoms. So if you want to break a bond between these two atoms, it required 435.8 kilojoules per mole. In oxygen molecule, the two oxygen atoms are bonded with a double bond. To break this double bond, it required 498 kilojoules per mole. In nitrogen molecule, two nitrogen atoms are bonded by triple bond. So if you break this bond, it required 946 kilojoules per mole. So based on that, if the number of bonds increases between the bonded atom, the bond energy also increases. Next is atomic size of bonded atom. See the halogens. Fluorine has the smallest atomic radii compared to iodine. So from top to bottom, atomic radii, atomic size is increases. If the size is small, then the atoms are overlap with each other. So it required high energy to break that bond between these two atoms. So from that, halogens, from fluorine to iodine, the bond energy decreases. Okay, next one is number of lone pairs of electrons on bonded atom. See the example of methane, ammonia and water molecule. In methane there is no lone pairs, and ammonia has only one pair of lone pairs, and water molecule has two pair of lone pairs. So the bond energy is inversely proportional to number of lone pairs of bonded atom. So if the number of lone pairs increases on the bonded atom, the bond energy decreases. Now tell me the decreasing order of this bond energy. So these are the factors which affecting the bond energy. Previous class we discussed about ionic bond and covalent bond. Now let's see the polarity of bonds. Here see the water molecule. Central atom oxygen is bonded with two hydrogen atoms. So the electrons are distributed among these three atoms. So the polarity of bond means the distribution of electrical charge over the atoms joined by the bond is called polarity of bonds. Here these polarity of bonds are mainly three types, that is non-polar covalent bonds, polar covalent bonds and ionic bond. See the first one is non-polar covalent bonds. When covalent bond is formed between two similar atoms like hydrogen, oxygen, chlorine, nitrogen and fluorine. So the shared pair of electrons is equally attracted by the two atoms. As a result, electron pair is situated exactly between the two identical nuclei. So the bond is formed is called non-polar covalent bond. So there is no charge created on this two bonded atom. That is called non-polar covalent bond. Next one is polar covalent bond. See the example of HCl. Here, see, chlorine is the highest electronegative atom and hydrogen is the least electronegative atom. So, this chlorine is what attracted the bond pair electrons towards itself. So, it is created a partially negative charge on the chlorine atom. Then hydrogen gets a partially positive charge. So, the polar covalent bond means bonds where electrons are shared unequally between atoms with different electronegativities, result in a partial positive charge on one atom and a partial negative charge on the other atom. Next one is ionic bond. Ionic bond means already we know that the electrons the atom completely transfer one or more electrons to another atom is called ionic bond. So the here see the example of NaCl. Sodium donate one electron to chlorine and it forms a sodium cation, and chlorine gets receive one electron from the sodium and it gets a Cl minus anion. So it creates a two ions, that is called ionic bond. Now, so as a result of polarization, the molecule possesses the dipole moment, which can be defined as the product of magnitude of the charge and the distance between the center of positive and negative charges. So it is usually designated by a Greek letter mu. So see the formula of dipole moment, mu is equal to charge into distance. Distance means the distance between the two charges. Next, this dipole moment is usually expressed in dB units, that is D. 1 D is equal to 3.33564 into 10 to the power of minus 30 coulombs and meters. So dipole moment is represented by the crossed arrow. So this crossed arrow, the cross is on the positive end and arrowhead is on negative end. For example, see the dipole moment of hydrochloric acid HCl. So this crossed arrow on hydrogen atom and headed is chlorine. So these arrows symbolize the distribution direction of the shift of electrons density in the molecule. So this is the polarity of bonds. See the example of hydrogen, oxygen and nitrogen molecule. In hydrogen molecule, two hydrogen atoms are bonded with single bond. In oxygen molecule, two oxygen atoms are bonded with a double bond. And in nitrogen molecule, two nitrogen atoms are bonded with a triple bond. So the number of bonds between the two atoms in a molecule is called bond order. Now tell me the hydrogen molecule bond order. Yeah, it is 1 because there is only single bond. In oxygen, 2 because double bond is there. In nitrogen, 3 because two atoms are bonded with triple bond, 3. But in isoelectronic molecules or ions means the same number of electrons. These molecules or ions possess same number of electrons. They show the same bond order. For example, fluorine and oxygen minus 2 ion shows bond order 1, and in nitrogen carbon monoxide shows 3 bond order. So if the bond order increases, bond enthalpy increases, but bond length is decreases. Now we'll write the Lewis dot structure of ozone molecule. We already know that how to write a Lewis dot structure. So we must follow certain rules. First one is identify count the total number of valency electrons. So here there are 3 oxygen atoms are present and valency electron is 6. So 3 into 6 means total number of valency electrons are 18 valency electrons. And second one is identify the central atom. So the middle oxygen atom is considered as central atom. Then draw a single bond between oxygen atom. If you draw a single bond between oxygen atom, then place the remaining electrons around the oxygen atom. Remember that each atom must follow octet rule. If it is not satisfy the octet rule, then what we have to do? Make a double bonds between this oxygen atom. Then we'll get two types of Lewis dot structures. So it is not possible to represent two Lewis dot structures. So they introduced a new concept, that is resonance. So according to the concept of resonance, where a single Lewis structure cannot describe a molecule accurately, So a number of structures with similar energy positions of atomic nuclei, bonding and non-bonding pairs of electrons are taken as the canonical structure of the real structure, which described the molecule accurately. So here the two structures shown are called as canonical structures or resonance structures, and the third structure represents the structure of ozone more accurately. So it is called resonance hybrid. So this resonance is represented by a double-headed arrow. Now we'll